Okay, so we have the question. We're given three vectors, v1, v2, and v3. And here they are. And we're asked to see if they can be, if there's some sum of multiples that adds up to this vector. That's going to be our vector v. Okay, well, v1 is this, v2 is this, v3 is this. So, here's our equation. We're given the vectors, so we plug them in. And now our equation is this. Okay, and then we proceed just as we did before. We do exactly the same things, except that now we've got three numbers in each column, and we've got three vectors. How's that going to make things any different? Well, we just do what we did before. What's the next thing we did once we had things written out in this manner? We multiplied C1 through this, we multiplied this one by C2, we multiplied this one by C3. Now we only had a C1 and C2, and the vectors weren't as long, but the multiplication is very similar, so you get C1, C1, 2C1, plus negative 2C2, 3C2, C2. And check me on this. 2C3, negative 3C3, 3C3. And that's equal to 2, 4, negative 5. And then we can add these three vectors. We get C1 minus 2C2 plus 2C3, C1 plus 3C2 minus 3C3, 2C1 plus C2 plus 3C3, and that's going to be equal to 2, 4, 5. Vector 2, 4, 5. On the worksheet I had commas for this vector when it should have been semicolons, so I wrote that down, but I'm going to take that away because hopefully I'll remember to correct that. On the document. Okay, so now what? Well, this is three equations, okay? Now, there are two things we can do with this, okay? We can write this as three simultaneous equations, which we could then rewrite as an augmented matrix and reduce. Or we could write this as a matrix equation. I'm going to write it directly as a matrix equation to start with, and then I'll write the system and so forth. Okay, well, the matrix equation is just what? 1, negative 2, 2, multiplied by C1, C2, C3. And we can see that if I multiply this, I get C1 minus 2C2 plus 2C3, which is our first row here. So this row times this column gives us this row. Then we have 1, 3, negative 3, and you can verify that this row times this column gives us this row. And then we have 2, 1, 3, and you can verify that that row times this row gives us the third row of this matrix. So that the left-hand side of the matrix can be written this way. In the right-hand side as 2, 4, 5. And this is of the form AX equals B. And we multiply both sides by A inverse, as we've seen for examples with 2 by 2 matrices. So this equals the inverse of this matrix multiplied by 2, 4, 5. Now you don't know how to get the inverse of this matrix, but you will soon. So let's just put it right. 1, negative 2, 2, 1, 3, negative 3, 2, 1, 3, inverse. You calculate the inverse of this, we can multiply it by this and get our values of C1, C2, and C3. Now we could also write, of course, this as the system. C1 minus 2C2 plus 2C3 equals 2. C1 plus 3C2 minus 3C3 equals 4. 2C1 plus C2 plus 3C3 equals 5, which is equivalent to the augmented matrix 1, negative 2, 2, 2, 1, 3, negative 3, 4, 2, 1, 3, 5. And I'll comment that this matrix here is just the first 3 columns of this matrix. So this matrix here, the first 3 columns of this matrix are the same as this matrix. And we want to reduce this matrix, if possible, to the identity matrix. Well, doing the inverse involves reducing this matrix to the identity matrix. So if we can reduce the matrix to the identity matrix, that means we have a solution. If we can't, it means either we have no solution or we have multiple solutions. And if we can't reduce this to the identity, then it doesn't have an inverse. And this doesn't work, but this still gives us information about the solutions. Now we're going to see all that in problems, but that's kind of an overview of what you can get out of this.